Alright, you little mathematicians. We are moving on to our new unit, solving algebraic equations. So this is the first video in a two-part series where we're going to solve algebraic equations using addition and subtraction. Now, equations are mathematical statements that have an equal sign. So you can think of them as like scales that need to be balanced. Each side of an equation has to be the same. And if you change one side of a scale, you must change the other side in the same way in order to keep the scale balanced. You can kind of think of these scales as like a seesaw, right? If the seesaw is perfectly balanced like this, not leaning one way or the other, then if I add something to this side, in order to keep the seesaw or the scale balanced, I better add something of the same weight to this side. So we're going to think of this drawing. These are like little marbles, these little blue dots. Let's call them marbles. And this box here is a box of some amount of marbles. We don't know how many, right? We can't see inside. So just to further illustrate, if I want to add another marble to this side, in order to keep this scale or this seesaw balanced, I better add one more to this side. Now let's say that what I'm interested in doing is finding out how many marbles are in the box. We also have to assume for this discussion that the box itself doesn't weigh anything and only the marbles inside the box are contributing to the weight that's pushing down this scale. So if I want to find out how many marbles are in this box, one way I can do that is by taking a marble off this side, which means I also have to take a marble off of this side to keep the scale balanced. Then I can take this marble off this side, take this one off here. Now the scales will still be balanced, and we can see the amount of marbles that must be in here has to be the same as the amount of marbles over here. So we could say x equals 4. Of course, not all the problems we see will have a picture of a scale like this, and we'll just get an algebraic equation that looks like this. X plus 2 equals 6. And that's an equation that represents our picture because we have x plus 2 equals these 6 marbles. Now when we're solving algebraically, we want to do this thing that we're going to call getting x alone. We want to get x alone to be able to figure out what it is. So the way we can do that here is by subtracting 2 from each side of our equation, just like we did on that last slide when I was taking the 2 marbles off of each side of the scale, right? That's the same thing. Now when we subtract 2 over here, we're just left with x. And when we subtract 2 over here, 6 minus 2, of course, is 4. You can see that x equals 4. I just solved this equation algebraically. Now, before I move on, I want to make sure that I check my answer. So I'm going to plug this 4 in for x and see if I come up with a true statement. Is it true that 4 plus 2 equals 6? Yes, it is. So I know I've done my problem correctly. Now when we're solving algebraically, one sort of hint we can use to help us know what to do in any particular situation is kind of illustrated by this table here or by this sentence here. The operation we perform is always the opposite, or the technical term would be the inverse of the operation that we are given. So in this equation, we are given a subtraction, right? We're subtracting 6. Well, if we're given a subtraction, then what we do is addition. So if the equation says subtract 6, when I want to solve for x, what I do is I add 6 to both sides. You need to make sure you do it to both sides, right? Whatever you do to one side of the scale, you have to do to the other if we're going to keep it balanced. Now x minus 6 plus 6, that's just x. And 9 plus 6 is 15. So x, in this case, would equal 15. And now we can check our answer by plugging in 15 for x. Is it true 15 minus 6 equals 9? Yes, that is true. So I know I've got my correct answer. I checked my answer. Now in this case, the operation that we're given is addition, adding 13. So if we're given addition, what we perform is subtraction. Instead of adding 13, we're going to subtract 13. And again, we have to do it to both sides in order to keep our scale balanced. So x plus 13 minus 13, that just leaves us with x. 17 minus 13, that leaves us with 4. So in this algebraic expression, x must equal 4. And of course, we can check our answer by plugging in 4 for x. So 4 plus 13 does equal 17, so I know my answer is correct. Alright, I know this is a little bit confusing, right? We're doing some real algebra, messing with algebraic equations. This is tough stuff. So if you're feeling a little confused at first, that's alright. I want you to go back, watch the video again, keep the scales in mind, right? Remember, whatever you do to one side of the scale or the seesaw, you have to do to both sides. So don't worry, mellow out, have a nice night, and we'll see you tomorrow.